6:15. All right, in this unit, we're going to be working on transformations. The first kind we're going to do is a reflection, where you take a figure and you flip it over. That's what we're going to be doing. So we have two learning targets in this section. We're going to draw reflections in a plane, in a coordinate plane, using paper. We're not going to use transparencies, even though that's what the standard says, because they can't ask you that on a standardized test, so I'm not worried about it. Graph paper, tracing paper, we're not going to do that. Or software, and we're not going to do that one, because again, they can't ask you that on a standardized test. And then I put another learning target in here, and I put this one in. This isn't actually part of the standards, but it kind of strikes me as being odd to be working with reflections if you don't know what one is. So we need to know what a reflection is. Okay? On page 615, a reflection in a line maps a point to its image such that, and then two things have to happen. If the point is on the line of reflection, then the image and the pre-image are the same point. So if you look at this figure right here, K is the line of reflection. Point A is on the line of reflection. When you flip point A over the line of reflection, it stays on the line of reflection. So that's nice, right? It'd be awesome if you had a bunch of those. Okay? So when a point is on the line of reflection, it doesn't move. When the figure gets reflected, that particular point doesn't move. Okay? Next, if a point does not lie on the line, and obviously this is where we're going to spend most of our time, then the line, meaning the line of reflection, is the perpendicular bisector of the segment joining the 2 points, joining the pre-image and the image, the old point and the new point. So if we look at this second figure here, we start with point A right here. K is the line of reflection. So A is going to be reflected and become A prime, or point A is the old figure, point A prime is the new figure. A is the pre-image, A prime is the image. So there must be a segment that connects the old point and the new point. And that segment is drawn so that it is perpendicular to the line of reflection and it gets bisected by the line of reflection. Okay? Because see, that's not there yet when we start. We've got a line of reflection. We've got point A. So we will have to make a line that starts at A and is perpendicular to the line of reflection. Then we will have to measure the distance from point A to the line of reflection and then put A prime that exact same distance away on the other side of the line of reflection. That makes the line of reflection the perpendicular bisector of that segment, doesn't it? And then for now, I'll erase that, but I don't have to erase that extra. Okay? You with me? So that's the process. That's how we reflect the figure. We reflect each vertex in the line of reflection. So we'll have all the points on the other side then, and then we connect them up and make the new triangle, quadrilateral, pentagon, whatever it is. So here's the way the book explains it. In example 1, still on page 615, we start with triangle ABC and a line of reflection K. What we do is we draw a line that goes through A and is perpendicular to the line of reflection and make it keep on going over here on the other side. We do the same thing with B. Make sure that line's perpendicular to the line of reflection. Make a line from C. Make sure it's perpendicular to the line of reflection. Then we measure the distance from A to the line of reflection. We measure that same distance on the other side. That's how we know where to put A prime. We measure the distance from B to the line of reflection, measure that same distance on the other side of the line of reflection. That's how we know where to put B prime. Measure that distance, measure that distance. That's how we know where to put C prime. Then you connect your points, and that new triangle is the reflection of the original triangle. Okay? do something. Page 619, this is part of your assignment. So, start off, it says copy the figure and the given line of reflection. So you're just make your figure, use your straight edge now. Don't freehand anything. Just like with constructions, we didn't freehand anything. With these transformations, don't freehand any of it. Use your straight edge to make a triangle that looks sort of kind of like that triangle CDF. Make yourself a horizontal line of reflection, call it line A, and then I'll show you what to do from there. Notice that it's okay. You can put point D on the line of reflection. D will be easy to reflect. All right, so once you get your figure drawn on your paper, stop. Let's do this first one together. All right. Everybody's got this? What we do first is we make a line. I'm going to make mine a dotted line. You don't have to make yours a dotted line. Okay? And we're going to start at point C, and you're just going to have to do your best estimate of making that perpendicular to your line of reflection. Just get as close as you can to making those lines perpendicular. So since we're just kind of eyeballing that, are our reflections going to be perfect? No, they're not. Okay? They're just not. Now, point D, D prime is going to be point D, isn't it? So we don't have to worry about that one. And then let's make a line from F and do your best to make it perpendicular to the line of reflection. So using your straight edge for everything. Don't freehand anything. What we do next is we take our compass and we use it as a measurement instrument like we did with constructions. We're not going to use it to draw circles. We're using it to measure. So let's take the compass. Let's put the point at point C. Wow, what a point. That's lucky. And pull around with it until you have the exact distance from C to the line of reflection. Everybody see the way my compass is? Now, move the compass point, stay on that little dotted segment, or on your segment you drew. Move the compass point to where the segment crosses the line of reflection, and make a little arc on your segment on the other side of the line of reflection. And guess what? That's where C prime goes. So we've reflected C prime. We know where D prime goes, don't we? D prime is right there where D is. And so now we need to reflect point F. So do the same process. Put the compass point right on point F. Work with your compass until you have the pencil right on the line of reflection. So I've got the compass point on point F. I've got the pencil on the line of reflection where my dotted segment crosses it. Then I move the compass point to where my dotted segment crosses the line of reflection. Make a little arc. And that's where F prime goes. So we now have C prime, D prime, and F prime. Let's see. use our straight edge to connect C prime, D prime, and F prime. And that's not what I want to do. Okay, why is that happening? Okay. I want to use shape transformation. There we go. All right, so I'm going to connect C prime, D prime, and F prime using my straight edge. And like with constructions, leave all your marks. That way I can tell that you've done the process correctly. And now that I think about it, if you make your dotted line, where I put the dotted lines, if you do dotted as well or dashed, it will make it a little easier to see what's going on, won't it? Okay, so make your little segments there dashed as well, and I think that'll make that easier. Well, that's not so bad, is it? Okay, let's do number two. As with anything, you can make it more difficult by making more points to move. Okay, so this time, go ahead and use your straight edge and draw a quadrilateral QRST and line of reflection K. Make it all a little bit slanted. That makes it a little more difficult too. When you're dealing with things that are horizontal or vertical, it tends to be easier to eyeball it and get 90 degrees when you need to. So let's challenge ourselves here. All right. Everybody ready? Let's start at R, and let's make a dotted line, and let's make it as close to perpendicular to that line of reflection as you can. Now, here's a hint to help you keep it straight, okay? It's got to be perpendicular to the line of reflection. Since all of the lines, all the dotted lines we're going to make are perpendicular to the line of reflection, shouldn't they all be parallel to each other? So that's one way to tell if you're getting it right. If all of your dotted lines are parallel, you're probably in pretty good shape. If they're not, then you're off somewhere. And it's, we're going by how it looks, so it's easy to be off. And you should have something that looks kind of like what mine looks like. Do you? Question? You didn't do anything wrong. Your figure is just a little bit, looks a little bit different than mine. That's okay. You'll just use that. What happened is her Q and her S, when she do the dotted lines, they end up, the same dotted line goes through both of them. And that can happen. So Q prime and S prime will just be on that same dotted line on the other side of the line of reflection. That's one of those things. You don't really, if you tried to make that happen, you probably couldn't. But it did. I said, okay. All right, now let's start measuring. So let's measure the distance from R to the line of reflection. I'll put the point right on R. I'll stretch my compass pencil out until it meets where the dotted line crosses the line of reflection. So that's the distance from R to the line of reflection. I have to put R prime the exact same distance away on the other side of the line of reflection. That's where R prime goes. And then y'all know the drill, at least I think you do. I'm going to do the same thing for Q. And I'm going to do the same thing for S. And last for T. Notice that I made the dotted lines longer than necessary. If you make them too short, well, then you got to get your straight edge lined up back on there and make it a little longer so it'll fit. All right, so once I have R prime, Q prime, S prime, and T prime, then I'm going to connect using my straight edge. And Q prime, R prime, S prime, T prime is the reflection of QRST. You think you got it? All right, so we are now able to draw reflections in a plane. We're also going to draw reflections in a coordinate plane. Okay? We'll come back to number 3 if we have time. I need to get. I forgot about this one. This is a good one. Number 4. Leave a space for 3. You're going to need to do 3, or do them out of order. I don't care. Let's take a look at number 4. Taru is waiting at a cafe for a friend to bring him a ticket to a sold-out sporting event. At what point P along the street should the friend try to stop his car to minimize the distance Taru will have to walk from the cafe to the car and then to the arena entrance? All right, so what's going on here is that we need to get the shortest distance from point C to the street to point E. Okay? Now, you've always heard something like, the shortest distance between 2 points is a straight line. That's true. But we've got to go to the street first. So here's how you do this. Okay, I think it's kind of neat how it works out. Before I learned this, I always wondered how how mathematicians would figure something out like this. So here's how you do the answer. We're going to reflect point C. I even wrote it up here, over here. We're going to reflect point C in line S, the street, and then I'm going to place point P on line S so that E, P, and C prime are in a straight line because the shortest distance between 2 points is a straight line. So here's what I'm talking about. I'm going to reflect point C. So we know the drill now, don't we? So on your paper, make a quick sketch of point. You don't even have to, don't draw the building. Put point C and point E in a line of reflection there on your paper. Point C, point E, and a line of reflection. And we're going to reflect C in the street. We're going to use the street. And in fact, I'm going to use the near curb of the street because hopefully we're not going to make poor Taru go out to the middle of the road. Okay? We'll pull over to the side for him. All right? So let's make a dotted segment from C perpendicular to the street. Let's use our compass to measure the distance from C to the street. Then we'll measure the distance from the street to the other side. That's point C prime. Now, using your straight edge again, let's make a line from E to C prime. And see where the line from E to C prime crosses the line of reflection? That's point P, to park. That's where we need to park. That way, Tareu's path, and we're done. We've answered the question. That's where we need to park. But here's what's going on. Tareu leaves here, goes to here, gets the ticket, goes there, and we know that's the shortest distance because the distance from C to P and the distance from C prime to P have to be the same, right? So it's a straight line. Shortest distance between 2 points is a straight line. Okay? Pretty cool, huh? All right. Now let's look at what goes on here in a coordinate plane. First, things get simpler because if our line of reflection is either horizontal or vertical, we don't actually have to use a compass to measure distances, do we? We can just count spaces. So on a coordinate plane, it's the exact same idea. It's just really, it's easier to do because measuring the distances means counting spaces as opposed to manipulating your compass to get the distances. So on number 5, and if you don't have any graph paper, that's fine. Just draw you a coordinate plane. And on your coordinate plane, put A with coordinates 1, 1 on there. B has coordinates 2, negative 2. And then C is, let's see, 1, 2, 3, 4, 5, 6, 7, 2. So you don't have to make a big deal of it. Just make you an x-axis and a y-axis, and then put those 3 points at 1, 1, 2, negative 2, and 7, 2. So when you're working these problems on your own in a little bit, it's okay for things to not be perfect. Now, our line of reflection, since the directions say to graph triangle ABC and its image in the given line. So we've graphed triangle ABC. Now we need to graph the line of reflection. The line of reflection is y equals negative 2. Well, y equals negative 2 is a horizontal line. So I'm going to make a horizontal line right here. That's the line y equals negative 2. We don't have to draw in dotted lines because we can use the coordinate plane. Okay? So if A, well, you tell me, how many spaces above the line of reflection is point A? 3. So shouldn't A prime be 3 spaces on the other side of the line of reflection? So, 1, 2, 3. That's where A prime goes. Where does B prime go? On the line. B and B prime are the same point. How many spaces above the line of reflection is point C? So C prime should be 4 spaces below the line of reflection. 1, 2, 3, 4. Use your straight edge to connect. And we have reflected triangle ABC in the line y equals negative 2. And now we know how to do a reflection in a coordinate plane. We okay with 5? All right, let's do 6. Go ahead and draw your graph for 6. This time A, well, A is 1, 1 again. B is it the exact, it's the same triangle, isn't it? B is still 2, negative 2, and C is still 7, 2. So we've got the exact same triangle, but we're going to have a different line of reflection. So once you get ABC on there, our line of reflection is x equals 3. Well, that's a vertical line. X equals 3 is vertical. 1, 2, it's right here. And then we do the same thing we did for number 5. It's just that we have a different line of reflection. Point A is 2 spaces to the left of the line of reflection. So A prime has to be 2 spaces to the right. How many spaces is B to the left of the line of reflection? So B prime has to be 1 to the other side. How many spaces away from the line of reflection is C? 4. So C prime has to be 4 spaces to the other side of the line of reflection. 4. Once you have A prime, B prime, and C prime, use your straight edge to draw your triangle. Questions? Okay. Now, we did those by counting spaces, and it worked out just fine, didn't it? If the line of reflection is one of the axes, we can count spaces. That'll always work. Or it always works this way. If your line of reflection is the x-axis, to reflect a point in the x-axis, multiply its y-coordinate by negative 1. In symbols, and I like the symbols, we'll use this kind of notation a little bit later too with translation. The point xy becomes, I like to think of the arrow as becomes. Technically it's mapped onto, becomes the point x negative y. Because look, if the x-axis is your line of reflection, the x-axis is horizontal line. So if I reflect A in that horizontal line, its x-coordinate's not going to change, is it? A and A prime are going to have the same x-coordinate. B and B prime are going to have the same x-coordinate. But the y-coordinates are on the opposite sides of the x-axis, so one y-coordinate is positive, the one of its reflection must be negative. Make sense? So, to reflect A, this A, in the x-axis, if A is 4, 1, A prime has to be 4, negative 1. If B is 7, 3, B prime is 7, negative 3. Now, can you get away with doing these reflections without remembering that? Yes, because you can count spaces. But here's the thing. On a standardized test, what they'll do is they'll just ask you what the coordinates of the reflection are, and they won't give you a graph for you to work it out yourself. Now, you can draw your own graph and work it out yourself. But remember, standardized tests, time is usually an issue. I don't know if y'all have ever taken one difficult enough for time to be a big issue. But trust me, when you get to the ACT and end of course, time is an issue. So you need to remember that that's how it's done quickly. Okay? Then a similar thing happens when our line of reflection is the y-axis. When the line of reflection is the y-axis, it's the y-coordinate that stays the same, and it's the x-coordinate that changes sign. So to reflect a point in the y-axis, multiply its x-coordinate by negative 1. So the point xy becomes the point negative xy. So you can see here, A prime is negative 2, 3. Or started backwards, didn't I? A is positive 2, 3. A prime is negative 2, 3. B is 6, negative 4. B prime is negative 6, negative 4. So again, we can get away with not remembering that. We really can't because we can count spaces. Okay? But if you do remember it, it's sure going to help you out when time becomes an issue. Let's see how this works. Number 7. Graph each figure and its image under the given reflection. So I'm cheating a little bit. I have a graph. You don't. Well, you might, but most of you don't. I'll see if I can find some graph paper in the next few days and give you guys some. So for number 7, we have triangle XYZ with vertices x, 0, 4. So x, 0, 1, 2, 3, 4. There's x. Y is negative 3, 4. 1, 2, 3. There's y. And z is negative 4, negative 1. And use a straight edge. Now, we can count spaces using the y-axis. You do know which one's the y-axis, right? The vertical one. That is your line of reflection. We can do that. But let's do this too. Let's go ahead and figure them out. X, y, x prime, y prime, z prime. And I wrote it down here again, so hopefully we can use this. To reflect a point in the y-axis, multiply its x-coordinate by negative 1. So if I take x, 0, 4, and multiply its x-coordinate by negative 1, well, 0 times negative 1 is still 0. Well, that makes sense, doesn't it? Since x is on the line of reflection, shouldn't x prime be the same point? So x prime is the same point. And then for y prime, y is negative 3, 4. If we multiply its x-coordinate by negative 1, now it's positive 3, 4 will be the coordinates of y prime. What are the coordinates of z prime? Right? Multiply the x-coordinate by negative 1. Y'all with me? All right, so x prime is the same point. Y prime is 3, 4. And z prime is 4, negative 1. Then we use a straight edge to connect our vertices. Any questions on 7? Now, we're still doing the same thing we were doing not in a coordinate plane. It really is the same thing because couldn't I make a dotted line from Z going this way and then measure the distance from Z to the line of reflection would be 4, whatever those spaces are. Then I'd move my compass over, measure that same distance. That's where Z prime would go, right? So we're still doing the same thing. We're just using the fact that it's on a coordinate plane to make the measuring easier. Well, and the perpendicular easier too, right? Okay? So we're using it to our advantage. To number 8, notice this one's reflected in the x-axis. And remember to use a straight edge when you're making your segments. And see if you ended up with something about like what I have. And keep in mind, if we make a segment connecting, let's say, R and R prime, that segment will be perpendicular to the line of reflection, and the distance from R to the line of reflection will be the same as the distance from R prime to the line of reflection. That'll be true for every one of those pair of corresponding points. Number 8 makes sense? Okay. One more thing. If our line of reflection is this line, y equals x, Okay? Y equals X is this line right here. Okay? It contains points like 1, 1, 2, 2, 3, 3. All right? Negative 1, negative 1, negative 2, negative 2. That's the line Y equals X. To reflect a point in the line Y equals X, you interchange the X and Y coordinates. So if the original point is XY, it becomes YX. So if the original point is 3, 2, its new point is 2, 3. You just switch them. You don't change the signs. You just switch the order. Okay? Let's do number 9. Because this time, we're reflecting this figure in the line Y equals X. So let's start with the points J, negative 3, 1. 1, 2, 3, 1. There's J. K is negative 1, 3. L is 1, 3. And M is negative 3, negative 1. So there's JKLM. To reflect a point in the line Y equals X, we need to interchange the X and Y coordinates. So if J was negative 3, 1, J prime is 1, negative 3. Just switch the order. That's all I'm doing. K was negative 1, 3, so K prime is 3, negative 1. L is 1, 3, so L prime is 3, 1. What are the coordinates of M prime? All right. So let's graph these. So J prime is 1, negative 3. K prime is 3, negative 1. L prime is 3, 1. And M prime is negative 1, negative 3. All right, now, I didn't draw the line of reflection in there. I did that on purpose because that's one, it's, this ought to work. If I connect the corners like that. Does that seem like the right line of reflection? Yeah. So the idea of learning to use your facts about what happens when your line of reflection is the x-axis, the y-axis, or the line y equals x, is so that you can do it without the line of reflection. Is there any rule that says that you're not allowed to put a line of reflection on there and then do what we learned originally? Yeah, go ahead, do it. Okay? Notice, if I draw a segment connecting L and L prime, perpendicular to the line of reflection, L and L prime are the same distance away from the line of reflection. I can do the same thing with J and J prime and all the, or M and M prime and all the others, can't I? Okay? So all we've done is learn different techniques on a coordinate plane to do what we did originally here. Okay? It's still the same thing. Questions? All right, there's a little summary on the bottom of page 618 of how it works out in a coordinate plane. It's worth your time and effort to remember that. Okay? And then here's your assignment.